Hello, everybody. We are back. I've got the doggy at my feet. We did like a 2-mile walk. I'm right up on the mic, so hopefully the volume stays consistent. I know, I apologize. Last video it was in and out and blah, 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 so I'm working on it. It's an iterative process. Bear with me. All right. Tonight we're going to have a little fun. We're going to do something a little different. And we're going to focus on mastering the basics as we've done. And instead of, hey, no, you stay right there. And instead of talking about mastering the basics, we're actually going to look at some of what I think are some very basic principles, super simple principles that are key for large-scale software development. This is not exhaustive in any stretch of the imagination. Not even close. But it's a few that I think are almost universally applicable. There's going to be corner cases where you can show that these things probably don't work, blah, blah, blah. But in general, what I found is these things can be very helpful, especially for large-scale software development. I'm not talking about the rapid prototyping. And as I think all of you know, when I'm talking about large-scale software development, I mean at least 1 million lines of code. Sometimes several million lines of code. So if you're in the space of even something like NATS, which I think is 350,000 lines of code, I don't consider that large scale. And that I don't mean that disrespectfully. I mean, it's just a different space. Different things happen when you reach a certain scale of code. And what I've seen is as code grows, the complexity is not linear. It's minimally superlinear. It's probably polynomial. It's multiplicative, essentially. And the reason for that will come into hopefully sharp clarity in a moment. But this is a slide deck that I think I presented a couple years ago at Merle. And I thought, what the heck, let's share this. And this is some of the stuff that I teach at the university, because my view is in order to effectively do machine programming, you really have to be an expert of the 4 domains: machine learning, software engineering, programming languages, and systems, minimally. And what I find is a lot of young folk today want to focus principally on the ML portion. And I get it. It's the shiny new toy. And it can feel very empowering. It's like riding a motorcycle or something, right? It's very flashy. And it's new. And you can see things happen right away. But without understanding those other 3 domains, I think that any level of expertise in machine learning in and of itself is probably insufficient to build a machine programming system that actually has like significant value, as well as potential strong technical differentiation. Anyway, let's take a look. And hopefully this is not only educational, but it's kind of fun. Now, this is sort of the way that I like to teach. Is I don't generally approach a topic head on. I kind of weave and wind and try to engage in a fundamentally different vector to get people's attention. So let's see what we got. Okay. So first, we need to understand what we mean by large-scale software development. This is a weak claim. It's meant to just give us a general approximation to define what large-scale software development is precisely. Is probably an impossibility problem, and all of us can disagree on it ad nauseum for forever. So this is just a ballpark. In my mind, it means it often scales to millions of lines of code, and that is it's not additive in terms of the complexity, it's multiplicative. Think of it not as a single road trip graph, but a graph of many, if not all, possible trips, and how crazy that map probably looks. On top of that, the code intention could be used for many years, oftentimes in ways that are not even understood when it's being written. That's a bit of a doozy, and 100% I have seen this, and I think it's a real problem. Oftentimes, one of the ways you can kind of tell, I think, if someone is an expert programmer, is they will start future-proofing things that are expected to be fundamental right out of the gate, and they'll do things like build in versioning, even though it's version 1. It's like, why are you building in versioning? Well, I suspect this is a core thing, and this software is going to grow to be something massive. So you build in the versioning now. So then by the time you get to version 2, you already have the versioning built in. So it's a seamless transition to 2, 3, and so on. Because if you don't build the versioning in from the get-go, how do you deal with version 2, right? So this is a real thing. And the key thing is not even understood today. Realizing that you are going to have things that people are going to use in ways that you can't even imagine right now. This is a pretty tall order. On top of that, the code that you're writing may become foundational to other code, and so on and so forth. And building it with that in mind from the get-go is likely going to save a lot of people a lot of heartache, including potentially yourself. And then the final piece to help us sort of understand what we mean by large-scale software development is that many, maybe thousands, maybe more, engineers and developers are likely to work on it. So it's not just a piece of software you're writing for you and your buddy. It's you're designing something with the anticipation that the whole world is going to eventually rely on this. So how do you do that? And a big part of it is really focusing on building, in my mind, this sort of key infrastructure that is going to be highly the word here is slipping my mind, but it's not mutable. Malleable, highly malleable, that you can massage it to do different things in a very easy way. I think the way they describe it in some of the software engineering books is loosely coupled, highly cohesive. Okay, so this is our working definition of large-scale software. All right. So this is kind of like textbook boring. Let's maybe get a little bit weird for a second. And let's fast forward to a TED Talk that Linus Torvalds gave. It looks like it's trying to say 7 years ago. I don't actually know. But this is a 20-minute talk, and it's really interesting because in most of the TED Talks, right, you got the person actually giving a talk, and I suspect Linus was sort of like, yeah, I'm not going to do that. Oh, do I have a link here? No. And instead, I'll do an interview. And so they're interviewing him on stage. And it's actually quite interesting interview. If you haven't seen it, I strongly recommend you check it out. I really like the way he kind of refutes some of the interviewers' attempt to focus on hype. And he grounds it, I think, really well. Like one of the questions that he asks that I absolutely loved Linus's answer for was he asks, what is it like to have written the operating system that runs the world? Like, what is it like to know that like several billion people or something are using Linux? And I think that the derivative there is the Android operating system, as I understand it, is derived in some capacity from the Linux kernel. And so if you consider all the people that are using Android, as well as just general Linux in all of its variants, it's supposedly the most used operating system on the planet today. So this interviewer is asking Linus, how does it feel? It must feel like, you're God or something, right? And I think a lot of people might answer this in a way of pride or, kind of lean in of, yeah, I mean, it feels good. And all those haters, blah, 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 like, did it, told you. And Linus doesn't do that at all. In fact, if I recall correctly, what his response is was something to the effect of, yeah, I don't really know anything about that, nor do I really think about that. And I got to be honest, I'm kind of the same way. That what I really care about on things like GTT or with Merle or at the university is I care about really high quality people like my buddy Mur, who I'm building like a lot of respect for just hearing and reading his or her comments. And same thing with interpretable metaphor, right? And I could have 10 gazillion subscribers and I don't really care about that. I care about the two high quality people that I can engage with and I learn things from. And so what Linus says in this is he says, yeah, I don't know anything about this, the billion users and stuff, but I will tell you that the stuff that I do know and the part that really did matter is when I was first doing this, what really made a difference is that there were a handful of people that when I was starting the Linux project as a lowly grad student, I had kind of no idea what I was doing. A few people rallied around me and supported me and believed in me and worked with me, even though I had no idea what I was doing. I had something that was not totally baked, and I didn't even have the capacity to build something incredible. And I love that answer. I think that's it's so grounded. And I also think that it's so anti-hypey that it just really resonates with me. And I think he's promoting the right type of thing that ultimately, I think, as I've discussed with Taylor many times, it's oftentimes what we end up doing in life is getting a huge amount of support and belief in us after we've already won. That's not when we need it. When we really need it, it's when we're in the muck, when we're in the trenches, before we're famous, before Linus has 100 million or a billion people using Linux. He needs it when he's a grad student and he's clueless and needs good mentorship, which is very much like what happened to me in grad school when Morris Herlihy, for God knows why, decided that he would mentor me. To this day, I still don't know why. Maybe he'll tell me at some point, but I'm just blessed. And I'm infinitely grateful. In fact, this is something that I try to practice every day, is just general gratefulness. In fact, this is one of my tricks to overcoming this weakness. One of the ways that helps me judge others less harshly is by practicing being grateful. Because it's really hard to be, at least I found it to be really hard to be judgy and spiteful when you're sitting around thinking about how grateful you are to have the people in the network that you have or supporting you or this type of thing. So anyway, Linus gives this response and it's brilliant and I absolutely love it. And he says a whole bunch of other really cool things in this. But then he goes on to talk about this. Now keep in mind, this is a TED Talk and it's viewed by, well, I don't know. I think that it says some number of million views, has 134,000 upvotes, 24 million subscribers for TED. So a number of people have seen this. So what does he talk about? Well, he talks about code, of course. And he makes this comment that I'm going to show you two pieces of code, and we're going to give everybody a moment to look at these, and then we're going to talk about it. But Linus says the code on the left is worse than the code on the right. All right, so let's take a look. Here's the code on the left, and here's the code on the right. Now, I'm going to give all of you a moment to look at this and try to synthesize all of these instructions. One more time, Linus says the code on the left is worse than the code on the right. And what we're really after here is why. Oh, and by the way, I kind of reduced the syntax, I think, a little bit, mostly so it would fit on this slide. But I think that entry, prev, and walk, they're pointers and this kind of stuff. So hopefully you can kind of intuit. I know many of you are expert programmers, so you already have intuited the definitions of things. I apologize for eliding away some of those details. It was just too much code to get on a single slide. Okay, now I'm going to talk about this. And so if you would like to look at this code some more, I recommend you pause it so you can think about it before I dive in. Now, I can't remember if Linus shares why he thinks the code on the left is worse than the right. But I can share with you one, that I agree with Linus, and two, that I have a very clear reason why the code on the left is worse than the right. And the reasoning is, in fact, maybe Linus does talk about this. Maybe someone can rewatch that TED Talk and let me know. So I think he argues that it has to do with good taste. And I kind of agree with that, but I think it has more to do with being able to simplify and understand the dangers of complex code. So very simply, the reason why I think the code on the right is better, especially for large-scale software, than the code on the left is because there is no special case. There's no special case. All the code follows the same logic. If it's the head node, if it's anything in the list, or if it's the tail node, it's the same logic every time. But for the code on the left, you can very clearly see at the bottom that if this does not have a prev, meaning this is the head of the list, you have to do something special. And for all other cases, you can do this. Now, this may seem like a really silly thing. Goju, it's one condition. Look at this. The condition itself is so simple. Why would this matter? Well, it turns out that when you're building large-scale software and you have things like this that not only create additional branches and can actually slow the program down in non-trivial ways if executed in a very hot loop, it's more of the mental tax, in my mind, that this introduces. That this is unnecessary mental tax that this code simply does not have. You just follow it through. Like we were discussing before, this whole notion of never nesting. Part of the reason why we want to reduce the levels of nesting is so you don't have to carry these things in your head. They just follow a single level of nesting, and all the various whatever things they exit. So you keep the nesting right at the beginning, right at the first level. So this is my view, and maybe this is what Linus says. And I think that's cool, right? But I think that there's something even more interesting going on here, which I like even more than the point that Linus is making about these two things. And that's on this slide. If we look at Linus's talk, we can see the interest going up and down. And the part where he talks about the code is the most replayed in the entire 21-minute talk. People are watching this 2x or something more than all the other sections. So they're clearly like leaning in to the code part, like trying to so here you can see, oh, look, looks like maybe, did I drop this on? No, that was, so that's from his thing. Yeah, so that was his code. Looks like maybe I didn't reduce it. Huh, cool, I feel even better now. So clearly people are paying a lot of attention to this piece, trying to understand like what is the deal. Okay. So let's go a little bit deeper and let's ask a very simple question. If you're going to talk to potentially millions of viewers and you're Linus Torvalds and there's a gazillion things that you could talk about, why would you spend approximately 15% of your 21-minute talk focusing on the remove operation in a linked list? Right? It's a remove operation in a linked list. And Linus is talking to millions of people. And he had prepared this example. It isn't an accident. He's choosing to focus on this. Why on earth would he do this? I think I know the answer. And I think it's very similar for the reason why we created Merly. And it's this. Code quality matters. It's arguably one of the most important things, especially for large-scale software. And therefore, from that lens, I think that's exactly the right thing to spend 15% of his TED Talk on that's going to be viewed by millions of people, because he's making, in my mind, a very simple point, which is it's not about the billions of users. It's not about the millions of lines of code. It's about having a deep level of care for the small things. Because when you care about the small things, those small things end up becoming the big things. And this goes back to our point on mastering the basics. And most things are basic. So now to go a little bit further with this, there are some additional principles that I would follow up on from Linus's point on the right code being better than the left code, which sort of reinforce, I think, some of his views on he really likes working with people that have good taste, something he says quite frequently. So let's look at some of those real quickly. Again, non-exhaustive. And there's likely going to be corner cases, but my personal experience and the experience of many of the other experts I've worked with, I think these are good things to follow. Thing number one, minimize complexity. Anytime that you can make the code simpler, you probably should. There are some cases where it's more important. Code that is going to be critical to the system, probably want to make as simple as possible. Code that is already very complex, you might want to try to find ways to simplify that. And code that I think maybe is just generally unusual. It's doing something that's not very common. And so people might struggle to understand it purely based on the novelty of the thing that you're building. There's probably more cases, but this may give you a starting point. Again, if you're working on a large scale system, you may be of the mind, well, there's so many things to minimize the complexity of where do I start? Maybe those give you some starting points, like what we saw in the ClickHouse code, where you have 7 layers of nesting, and it's like, okay, this is sort of an easy target because this code is pretty confusing. All right. Next rule, minimize repeating yourself. In other words, don't copy and paste your code. Simple, very simple. Urs has a rule, I think, that he will allow himself to do copy paste up to 2 times, but by the 3rd time, he kills it. So if he finds that he's copy pasted more than twice, he's getting ready to do it a 3rd time, he stops and says, nope, it's function time. I'm not going to allow myself to repeat this. I try to follow a similar principle. I personally try to not use the Control C, Control V keys when writing code. It's quite hard. I think you've seen me do it, where I'll type something out and I'll intentionally go slower because I won't hit the copy paste. I've had hundreds of bugs come into my code because of careless copy and paste. Simple things. Copy paste looks totally right. Goes through code review, no problem. Turns out we forgot to change one literal. Had I typed it out and spent the extra 2 minutes actually writing it myself rather than copy pasting, the likelihood of getting that literal wrong would probably approach 0. But because I was trying to save time, what I ended up doing actually is costing more time. So strongly recommend you don't do that. And one of the things that Mentor, I think, is super good at is identifying these kind of like copy paste issues. So let's just go to some random repo that is doesn't have like, okay, that's not a good one. Let's pick this guy maybe. Okay, we've got 134 issues. Here you go, copy paste. Here you go, copy paste. Here you go, copy paste. Right? Look at this. Copy. Yeah, I mean, just don't copy paste. And Mentor's like, I think one of its superpowers is because Mentor functions at a semantic level rather than a syntactic level, it does natural grouping of things that are not necessarily identical. It's essentially doing what you could think of as abstractions for a regular expression without you specifying what the regular expression is. For example, these 2 lines of code are identical. So grouping using some sort of value-based systems for the tokens would naturally group them together in the same with the same value, right? Not a big deal. Same thing here. These are identical lines of code, or at least they look like that. So you would expect that they'd be grouped together and get the same value. These lines of code, however, like these 3 and then these ones here, they're not identical. So this is set portal IPS is subset existing IP. This is set Azure Cloud IPS, not portal IPS, is subset existing IP. This one is set Azure Cloud IPS, is subset, it's on parts. This one's on portal IPS, on parts, not existing IP. But you'll notice that Mentor groups them all together. A key way to realize that Mentor is doing it is look at the first number. That is the unique identifier saying these lines of code appear to be semantically equivalent. And then the secondary number after the colon is giving you the instance. So there are 6 instances of essentially code that Mentor thinks are semantically equivalent in this code base that it's found right here. And I would argue, at least at a quick glance, that Mentor's probably right. these are essentially semantically equivalent, and the only variation really is the individual like variables that you're passing in. So, but you can think of it as saying A plus B plus C. And whatever the value A, B, and C is, it doesn't really matter in the sense that you could supply any number of numbers for A, B, and C, and those equations would be semantically equivalent in the general properties that they're adding three numbers together. So this is something that I think is really useful that Mentor does, because it gives you a quick sense of, is the repo copy pasting code? And what I generally find is that the repos that score less well tend to do copy pasted code. And again, what I really like about Mentor is because it's doing semantic analysis, it doesn't do exact matches on things, and it can see similarities, semantic equivalence, even when strings don't match exactly. And it does it all in a completely automatic way. You don't have to tell it to think semantically. It just like knows. And some of them I think are quite fascinating because they can appear at a high level to look really different. These two, for example, I guess are pretty close. But this second string is much longer. Wonder if there's any that jump out at me that are really different. Let's take a little bit more of a look here. Not too bad. So anyway, I mean, yeah, so it's kind of breaking my rule about the copy paste. Minimize complexity, minimize repeating yourself. And this one is, I think, in some sense, quite counterintuitive. And I wouldn't be surprised if some people push back on this. But this is actually something that I believe. I'm not saying this just to be provocative. It's my belief that code should actually be principally written for readability first, not correctness first. That's right. I think that the correctness of the code should be second to the readability of the code. This probably sounds like pure lunacy. But the reason why I believe this is that if the code is extremely readable, then if the code is not correct, it will likely be extremely obvious. However, if the code is written principally for correctness, and we're going to do whatever we can to make it correct, including sacrificing readability, the code may be correct right now. But one, software that's used is software that's maintained. Software that's maintained is software that's changing. Just because the code is correct today doesn't mean it's going to be correct tomorrow. And when we have to change code that is not readable, there's a greater likelihood that we are going to introduce bugs even to code that is correct. However, if we're writing code that is principally readable, again, even if it isn't correct, it should not be too hard, hopefully, to change that code so it is correct and continue to maintain readability. And if you go back to Linus's example, I think that this is in some sense, more complex, and it is less readable because of this case. Whereas this code over here, I think, is actually more readable. Because it follows the same logic. All you need to do is just understand the one case of how it executes, and then you understand all cases. Now, admittedly, he is allowing, I think, the head pointer to change its location. And so this is arguably more mentally taxing. But let's save that for another time. That's one of those things where it has layers. Okay. And also there's this quote that I absolutely love. There's generally two ways to write code: code that has no obvious bugs, or code that obviously has no bugs. And writing code in the second way tends to be significantly harder. Significantly harder. I know lots of junior developers that can write code that is wildly complex and nobody understands it, including them, and no one can tell if it has bugs. It has no obvious bugs, but only master level programmers can write code that is so simple that anyone can look at it and say, this code is correct. This is Yoda level stuff here. That's my strong conviction. The next piece is to write code that maintains itself. We've seen examples of that with like the enums and moving away from embedding literals, copy-pasted thing, massive run-on if statements, things of that nature. And then the last one, again, not an exhaustive, just meant to be a short starting point for some principles that we can use to write large-scale software. And this kind of dovetails with the minimizing complexity is don't code to show off. Don't. And keep in mind, I'm not saying that you shouldn't use these things, that you can't do polymorphism or templates or anonymous or lambda functions, stringization, stringification, whatever the heck we want to call it. If you don't know what this is, that's good. You shouldn't. But all of these things are extremely powerful, and sometimes they have a good place. They're useful, but I think they shouldn't be something that you go to as you're right out of the gate. Let's crank out with some new lambda functions or anonymous functions because it's just fun. And I have fallen victim to this for sure. I'm the guy that would be like, but let's templatize it now. So we got it working, but now let's make a template. Like you've seen me do this, and sometimes I get a little overzealous and I need to just chill out. And so I'm talking to myself when I'm saying this, that and when I'm doing it, I'm not even trying to show off. It's more just I get the theoretical mathematician in me comes out, and I think, oh, it's just more pure when there are no types. Like we were discussing last time, it has a pure sense as it could just work with all this code. And why would you not write it so it would work with all this stuff? And sometimes that's just not necessary. Sometimes by doing that, I'm sending us in the wrong direction because it appears like it's going to work in all these cases. But then for some specific case that I hadn't thought of, it doesn't work at all. And had I just written the function people wouldn't have had the ability to instantiate it for any type that they want, and then suddenly it is doing the bad thing. Yeah. And yeah, polymorphism in particular, what I really think of is these massive inheritance trees. It's just, yeah. So, and I'm not saying don't use polymorphism in its various forms, like parametric polymorphism or other types. Yeah, and we'll maybe go down, what the heck, we'll go down this rabbit hole at some point in the future and talk about the various forms of polymorphism, and just so we're educated on it. But the point is maybe don't jump into these things right out of the gate just to show that you can do cool stuff. It's good to learn these things and have these in your toolkit. And I think if you want to play around with more advanced features of various languages and stuff, do that. Like, for example, when I was coding in Lua and I found out that you can overload the Lua keywords to do whatever you want, I then had a weekend hackathon where I started overloading the Lua programming language and just coded up some totally crazy stuff. But that never got into production. I didn't build this into like a Game of War or Mobile Strike or anything like that, for good reason, because this would be ridiculous, right? It would be, it'd be really bad. So you can still play around, but just try to keep that stuff in your sandbox unless it's absolutely necessary for production. And then in that case, yeah, have at it. Okay. I think that's it. And yeah, this was just my, I think I copied this from some other slide deck. So I presented this to some of the Merly staff. So clearly all of them know about the company. Anyway, I was going to show an example of what kind of like good code looks like in this particular case. But since we saw examples of, I think, some of the bad code, maybe we'll just leave it at that for the time being. And I think that may be like especially true given that we have 2 GTT episodes today. Pretty happy about that. I think that might be a first. Not entirely sure, but feeling pretty good about it. And so, yeah, actually, while we're here, let's just, I want to look at, we need to talk about OpenSSL, but not right now. For sale. No, that's so many things to talk about. What do I want? React Native. I want to look at, this is what I want to look at, React Native. Look at this. What? Meta. What is going on, guys? Es no bueno. That's not good. It wasn't this bad before. I mean, I could see that it was moving in this direction, but so do you remember how I was saying about copy paste And you can usually get an indication on whether or not code is high quality or not based on certain simple principles. Again, just mastering the basics. Okay. I think, my goodness. I can't not click on this. I just have to know. Keep in mind, this is open source production quality code. This isn't make believe. Yeah. So, I think Benter's really. I was slowing down my camera there. That's actually kind of interesting. Whenever it's part of this, it's probably it's kind of humorous. It's probably a React thing from our JavaScript front end. So this is a single if statement, guys. Do you understand this? Because I don't. We might be able to understand this if we all spent maybe 4 hours dissecting it. But now ask yourself, who's going to come in and volunteer to maintain this code? When we need to expand the current feature set to do something additional for the commit hook effect list mount, and the product manager say, just add this small little feature to this. This will just take 5 minutes. And then you go and you open it up and you look at this and think, 5 minutes, huh? Okay. It's going to take me 10 hours just to understand this piece of code. Then, of course, the product managers come and say, what's the holdup, Bob? I don't understand. This was like just a simple little thing. Yeah. Minimize complexity. Code should principally be written for readability. This is what happens if you don't do this. Not great. And I'm not trying to pick on React Native, I promise. I understand writing software is hard, especially large-scale software. This doesn't even fit the large-scale definition that I have. But yeah, so this stuff matters. Quality matters. I'm with Linus. And I think that there are some very basic principles we can follow that if we do, we can make the world better, especially the world of software. So with that in mind, I hope you guys have a great rest of your evening and know that those of us over in GTT land, we're working hard on these principles, as well as those Merlians that are working around the clock to build stuff. Actually, I didn't even look. I mean, Mentor's got its hands full with this. What the heck? Let's see what Mentor thinks. Maybe this is why I was stalling my Sheen out, is Mentor's like, I have no idea. It's like, well, I mean, it's definitely breaking stuff down. I like that. So you can start. I mean, it's getting into a little bit of a never nesting, but can you blame it? I mean, this is still probably easier than this. Maybe in a subsequent episode, we'll actually try to break this down. Whew, man. Yeah, again, it's whew, man. This might actually be closer to the best rewrite, is to make a whole bunch of these different functions, and it looks like it may have overlooked some repetitiveness. No, it hasn't. It sees that these are different. Yeah. This is where you would pass in this. Oh, no, it's a type. Okay, I see. Yeah, it's going to take us a while to dissect this to see if Mentor is right. But I would take, seriously, guys, I would take this code 1,000,000 times over this code, because this code I can reason about in pieces. I can say, I know what this does. Has required flags. Got it. I can reason about this. Is passive effect. I know what this does. It does this, right? So I can slowly build up the knowledge in small pieces to understand what's going on. I don't have to try to do it all in one fell swoop, which is this. And so even though there's still a lot to process, Mentor is making my life significantly easier in that I can take it one piece at a time, essentially one byte at a time. So maybe in a future episode, we'll try to break this down and then break one of these down to see if Mentor got it right. But yeah, I think maybe this third one I like the most. So I'm going to just +1 this guy. I guess now we're on the hook for evaluating to make sure that it's approximately correct. Okay. Thanks, everybody. I hope you enjoyed the fun. I know me and the dog did. And we'll talk to you next time.